Hi everyone, this is Mr. H again and welcome back to my YouTube channel. In this video, I will discuss 3 different examples about derivatives. But if you haven't checked out my previous videos about finding the derivatives of trigonometric functions, exponential and logarithmic functions, implicit differentiation, I recommend that you watch all those videos and you can find the links to those videos in the description box below. Let's have a look at the first example. Alright, so for example number 1, we are asked to find the derivative of y cubed plus x cubed minus 3xy squared equals 0. Alright, so by just looking at the given, it actually tells us that the method that we need to apply here to find its derivative is what we call the implicit differentiation. So first we'll be getting the derivative of y cubed. So every time you differentiate a term with y variable, that is where the y prime starts to show up. So for example, y cubed will be 3y squared y prime. So again, for implicit differentiation, every time you differentiate a term with y variable, always remember to multiply it by y prime. Next is x cubed. So the derivative of x cubed is 3x squared. So applying the power rule. So since the variable is x, we don't need to multiply that by y prime. Okay? Only if the term has y variable in it. Alright, next is the third term. So the third term is this one. And as you can see from here, variables x and y are present in one term. So basically what we need to do here is we need to apply the product rule. Alright, so you have x factor and another factor which is y squared. So so we can separate 3 first and we need to apply the product rule for xy squared. So to apply the product rule, we take x first times the derivative of y squared. So it's going to be 2y y prime plus we take y squared times the derivative of x, which is 1, then equal to, so 0. Alright, so next thing we need to do is to simplify, especially the ones inside the brackets. Okay, so we just copy 3y squared y prime plus 3x squared, and then we copy -3 and simplify what's inside. So this one is going to be 2xy y prime plus y squared equals 0. The next thing is we can distribute this. So we copy 3y squared y prime plus 3x squared. So that's going to be -6xy y prime. So -3 times y squared is -3y squared equals 0. Now, so the next step we need to take is to gather all the terms with y prime on one side and the rest of the terms that do not have y prime will be separated and will be put to the other side of the equation. So by looking at all the terms from here, we can see that this term and this term has y prime, so we can leave them on the left hand side of the equation. And the other two terms that do not have y prime, we put them on the right hand side. So positive 3x squared will become negative 3x squared. And negative 3y squared will become positive 3y squared when moved to the right-hand side of the equation. If we look at the left-hand side of the equation, we can see that we can factor out y prime because remember, we're looking for the derivative. And derivative is y prime. 3 is also a common factor. So we can take out 3y prime. All right, so after taking out 3y prime, from this term, we are left with y squared. And from this term, we are left with 2xy. Also, for the right-hand side of the equation, we can see that there's a common factor, which is 3. We can take out 3 from here. And basically, we'll have negative x squared here. And here, positive y squared. And as you can see here, we have 3 on the left and 3 on the right-hand side. So definitely that cancels out. And we're left with y prime. So y squared minus 2xy equals, let's say, y squared minus x squared. All right. And since we're looking for the derivative, and you can see here y prime, we've already factored it out. All right, so in order for us to find y prime, we need to divide both sides by this whole thing. All right, so this one cancels out, or 1. So we're left with y prime on the left, and that's the derivative already. And we just simply copy everything on the right-hand side. And this is the answer. All right, so how do you find this example? If you find it interesting, let me know by leaving a comment down below. So let's head on to our second example. Find the derivative of g of x equals sine x plus 1 divided by cosine x plus 1. All right, so by looking at the given function, I am sure that some of you initially thought about quotient rule, which is actually correct. You can apply quotient rule here. And maybe some of you are more comfortable using another rule to find the derivative of this given function. You can always follow that as long as you do the math right. So rewriting it to this form actually tells you that we're gonna go for product rule. So g prime of x equals, we take the first factor, okay, 1 plus sine x times the derivative of the second factor. It will be negative 1 times the base, which is 1 plus cosine x. So negative 1 minus 1 is negative 2. And we need to find the derivative of the base. So derivative of 1 is 0, plus the derivative of cosine x is negative sine x. So that means this is multiplied by negative sine x. Plus, we take the second factor. So that is 1 plus cosine x to the power of negative 1 times the derivative of the first factor. So the derivative of sine x is cosine x. Derivative of 1 is 0. So basically, we multiply this by cosine x. Next is we simplify we simplify first this one inside the bracket, right? So g prime of x equals, we copy 1 plus sine x. And here we can say, so negative 1 times negative sine x is positive sine x. And then I simply copy this one. So 1 plus cosine x to the power of negative 2. We just simply copy everything here. Alright? Alright, so I can rewrite this because we have here negative exponent, so I can make this exponent positive. Same goes for this term. Alright, so g prime of x, so 1 plus sine x, just simply copy. So for this factor, we can rewrite it as sine x divided by 1 plus cosine x to the power of 2. And then we apply the same process here for the second term. So cosine x will be left in the numerator divided by 1 plus cosine x. And basically for the first term, we can write it as a single fraction, 1 plus sine x times sine x. So g prime of x equals, okay, so sine x times 1 plus sine x all over 1 plus cosine x squared. And we just simply copy the second term. Now, in order for us to write it as a single fraction, we need to multiply this term by another factor of 1 plus cosine x. So if you're going to expand this, it's going to be 1 plus cosine x times another 1 plus cosine x. But here we only have 1 plus cosine x. So that means in order for this to be the same as this one, we need to multiply both the numerator and the denominator by 1 plus cosine x, right? So we multiply this by 1 plus cosine x as well as the numerator. And then we carry on, so g prime of x. And now we can write it as a single fraction because now they have the same denominators. And the denominator is 1 plus cosine x to the power of 2. So basically here we just simply copy because we didn't multiply anything, plus cosine x times 1 plus cosine x, so we copy them first. All right, so the next step is we need to simplify the numerator by applying the distributive property. So we copy first the denominator. Here will be sine x times 1 is sine x. Sine x times sine x is sine squared x, plus cosine x times 1 is cosine x, plus cosine x times cosine x is cosine squared x. And from here we can see that this 2 is actually an identity, right? So we call it the Pythagorean identity. So if you can recall, sine squared x plus cosine squared x is equal to 1, right? So basically the numerator can be rewritten as sine x plus cosine x plus 1 all over quantity 1 plus cosine x to the power of 2. And if there's nothing we can do anymore, then that's the derivative. You don't need to expand the denominator. You can only expand it if something can be canceled out after doing that. But if there's nothing that can be canceled out after expanding it, then just leave it like that. Alright, so if you guys are enjoying this video, please hit the like button. If you haven't subscribed yet to my YouTube channel, please hit the subscribe button too and the notification bell so that you will be notified when a new video is uploaded on my YouTube channel. Alright, let's take a look at example number 3. So find the derivative of y equals negative sine of x squared plus sine squared x. So this is a straightforward differentiation. So we'll have y prime. So derivative of the first term. So our first term is negative sine of x squared. So the derivative of sine is cosine. So negative is there. So derivative of sine is cosine. And then we copy the angle, which is x squared. And remember to get the derivative of the angle. So the derivative of x squared is 2x. So that's times 2x. Plus the derivative of this one, sine squared x. And you know that sine squared x is the same as quantity sine of x to the power of 2. Alright? So we can find the derivative by putting down the 2 in front. So chain rule. And then we copy the base, sine x. Then we subtract 1 from the exponent. So 2 minus 1 is 1. But don't forget to get the derivative of the base. So the derivative of sine x is cosine x. So times cosine x. So y prime equals, so this is going to be negative 2x times cosine of x squared. The second term, it's 2 sine x times cosine x. So if you can recall sine double angle identity, so 2 sine x cosine x is actually equal to sine of 2x. So basically, this second term right here must be converted to this one. So the final answer here is this one. So remember to apply identities if there are identities that appeared in the solution, because the final answer must be the simplest form. Alright, that is all for this video, guys. So if you learned something new from this video, give me a thumbs up, share the video, and if you haven't subscribed yet to my YouTube channel, please do so. And once again, thank you very much for staying up until the end of this video, and I will see you in the next one.